Here is the solutions video to your absolute value homework. Alright, remember this is going to be collected to be graded next class. If you think that you did some of these right, feel free to skip ahead. Just watch what you need to watch, but remember I am collecting and grading this. Alrighty. And remember, we need to show all work. We need to show that we are breaking this into two cases, and we need to check your answer. If you do not include a check, I am taking points off. So if you need to do some work on extra paper. All right, break number one into the two cases. 3x equals 9, or 3x equals negative 9. So I get x is equal to 3, or x is equal to negative 3. I'll do a check. Remember, we always check in the original. So this is the absolute value of 3 times 3 equals 9. And that checks. I do my second check because you have to check both. And we get the absolute value of negative 9, and that's just 9. And boom, those both check. Woohoo! Moving on to number 2, don't have a heart attack because they're fractions. Remember, we don't mind fractions in this class. So this is x over 3 equals 2, or x over 3 is equal to negative 2. Solve for x by multiplying by 3, you get x is equal to 6, or x is equal to negative 6. Then we check. In the original, always in the original. So I plug in for x. 6 divided by 3 is just 2, so that's the absolute value of 2. 2 equals 2. That checks. Woohoo! Check the other one. Negative 6 divided by 3 is negative 2, and then you get 2 equals 2. That checks. Woohoo! Those are pretty wimpy. On to the more complicated. Alright, remember, we need to have the absolute value isolated before we can switch into two cases. That is very similar to what we talked about today with radical equations, alright? Look for the similar things in all of our procedures. We're always isolating the thing that gives us trouble. So here, I need to add 5 to both sides to get my absolute value alone. And then I have absolute value of x plus 8 is equal to 7. Now you can break it into the two cases. So x plus 8 equals 7, or x plus 8 equals negative 7. Subtract 8 from both sides, you get x is equal to negative 1, or x is equal to negative 15. You've got two answers. You need to do two checks in the original. So when I check negative 1, this is going to be the absolute value of negative 1 plus 8 minus 5 is equal to 2. That's the absolute value of 7. Simplify, and perfect. It checks. Got to do my other check. Now I'm going to check negative 15. I'll do that up here. So now I get the absolute value of negative 15 plus 8 minus 5 equals 2. Negative 15 plus 8, that's negative 7. The absolute value of negative 7 is just 7. And that checks as well. 2 equals 2. Booyah. Number 4, the absolute value is already isolated, so we can break it into our two cases. So I get, and I'm going to move this kind of towards the center so I have enough room. That's going to be 1 minus 5x is equal to 29, or 1 minus 5x is equal to negative 29. Subtract 1, I get negative 5x is equal to 28. Divide both sides by negative 5, x is equal to negative 28 over 5. We do not write this as a decimal. We do not try because it's a fraction. We just leave it. Fractions are okay in this class. Or, if I'm over in my other case, I subtract 1. I get negative 5x is equal to negative 30. Divide both sides by negative 5. I get x is equal to 6. So that's not bad. We had a funky fraction, but we also have a nice integer. And now I can do both of my checks in the original. So this is going to be the absolute value of 1 minus 5 times negative 28 over 5 is equal to 29. Now you can't put this in your calculator, but hopefully some of you are noticing that since I have 5 times something with a 5 in the denominator, these 5s are just going to cancel. And this minus a minus is just going to change to addition. But if you put this in your calculator, it still would have worked out. Just make sure you have those parentheses around the negative 28/5. And you are going to get the absolute value, whoop, wrong color, of 1. Let me make that nice. Woo, there we go. Alright, so this is going to be the absolute value of 1 plus 28, because those 5's canceled and the negatives cancel. And so that's the absolute value of positive 29, which is obviously 29. So that checks. Woohoo! Then I gotta check x equals 6. So I'm doing the absolute value of 1 minus 5 times 6 is equal to 29. That's going to be the absolute value of 1 minus 30, which is the absolute value of negative 29, which is 29. Woohoo! That checks. On to number 5. Also, already has the absolute value already isolated. I was really nice when I made this. Now we can break it into our two cases. So I've got 2x minus 1 equals 9, or 2x minus 1 equals negative 9. So I solve for x, I get 2x equals 10, x equals 5. Or over here, when you add 1 to negative 9, you get negative 8. Divide both sides by 2, you get x is equal to negative 4. And now we can check those. I think I can fit 1 down here. I'll check 5 down here. So now I got the absolute value of 2 times 5 minus 1. That's the absolute value of 10 minus 1, which is just the absolute value of 9. And you can't fit it in there. You get 9 is equal to 9. Woohoo! Now I'll check negative 4. So this is the absolute value of 2 times negative 4 minus 1, which I get negative 8 minus 1, which is the absolute value of negative 9, which is just 9. Woohoo! They check. The next one also has just the absolute value. My goodness. Alright, so our two cases, I've got 3 minus 2x equals 5, or 3 minus 2x equals negative 5. I'll subtract 3 from both sides, so this is negative 2x is equal to 2, which means that x is equal to negative 1 when you divide. Or if I come over here, I subtract the 3, that means negative 2x is equal to negative 8. And I get that x is equal to positive 4. Alright? And guys, I know I'm kind of going through this really fast. But remember, you're supposed to be checking your work to do this. Feel free to pause it if you need to take the time to make some corrections. Alright? That's the difference between me and class. You guys can't shut me up in class, but now you can pause. Alright? So let's do these checks. Remember, you check in the original. So this is the absolute value of 3 minus 2 times negative 1 equals 5. So this is the absolute value of 3, and then this is going to become plus 2, because the minus a minus. And that's the absolute value of 5. And you get 5 equals 5. Woohoo! Now we can check 4. So this is going to be the absolute value of 3 minus 8. So this is the absolute value of negative 5, which is just 5. Ooh. Ah, here we go. Absolute value is not isolated. We gotta move this 4 over. So this is still the absolute value of 2x minus 1. And when you subtract the 4 from both sides, you get 4. Now we can break into our two cases. So you get 2x minus 1 is equal to 4, or 2x minus 1 is equal to negative 4. Add 1 to both sides, you get 2x is equal to 5, or x is equal to... What happened there? Yeah, 2x is equal to 5, or x is equal to 5 over 2, which we do not write as a decimal. We do not panic because fractions are wonderful in this class. Or if I add 1 over here, I'm going to get 2x is equal to negative 3, or x is equal to negative 3 over 2. And we still do not panic that we got a second fraction because we love fractions. At least I do. Alright, now I'll extend my page and do my check. And remember, we're checking in the original. I'll check 5 halves first. This is the absolute value of 2 times 5 halves minus 1 plus 4 is equal to 8. Now, again, you could punch this in your calculator, but I've got 2 times something with a 2 in the denominator, so those are going to cancel. And so this is really just the absolute value of 5 minus 1 plus 4 equals 8. That's really the absolute value of 4. And the absolute value of 4 is just 4. So then we get 8 equals 8. Woohoo! And now I can do my other check of negative 3 halves. So we've got 2 times negative 3 halves minus 1, all that in the absolute value, plus 4 is equal to 8. Again, the 2's, bam, they cancel. So I get the absolute value of negative 3 minus 1 plus 4 is equal to 8. And that's negative 4 inside there. But the absolute value of negative 4 is positive 4. So again, I get 8 equals 8. Woohoo! 1 down. Oh, and then there's a back. I'm so mean. Whatever. Alright, where's the scroll down here? Ooh, okay. Ah! Alright, this one's a little trickier. Alright, the absolute value is isolated, but remember, we got to make everything negative for our negative case. So this is going to be 3x minus 1 is equal to x plus 5. Or 3x minus 1 is equal to, you could do like negative and then keep this in parentheses. Or a lot of you are going to just noticing that the sign switch. So it's going to be negative x minus 5. Alright, that's what would happen if you did the parentheses and then distributed. And now we can solve. I'll add 1, so I get 3x is equal to x plus 6 minus x. So 2x is equal to 6. I get x is equal to 3. Or, if I add 1, I get 3x is equal to negative x minus 4. I gotta add x, I get 4x is equal to negative 4. So x is equal to negative 1. Now I gotta check. In the original, so this is the absolute value of 3 times 3 minus 1 is equal to 3 plus 5. Whoop. What happened? So this is, there we go, 9 minus 1 is equal to 3 plus 5. So that's the absolute value of 8, which is equal to 8, and 8 is equal to 8. That checks. We can also check negative 1. So this is the absolute value of 3 times negative 1 minus 1, which is equal to negative 1 plus 5. This is going to be the absolute value of negative 3 minus 1, which is equal to negative 1 plus 5. This is going to give me negative 4 in my absolute value. I'm going to get 4 on the right, but the absolute value of negative 4 is 4, so I get 4 is equal to 4. Woo-hoo! Whoa, never done that one before, but it checks. Everything's good. Alright, and on to the back. This one is not really a curveball, alright, because we're still going to do the same process that we've been doing. We have to isolate the absolute value. First thing, subtract the 8 over. So I have 3 times the absolute value of negative 8x, which is equal to 72. Now this is 3 times the absolute value, so we're going to divide by 3. Alright, you cannot distribute this 3 into the absolute value. I hope none of you did that. When you divide both sides by 3, you're going to get the absolute value of negative 8x is equal to 24. And now we can break into those two cases. So negative 8x is equal to 24, or negative 8x is equal to negative 24. So we get x is equal to negative 3, or x is equal to positive 3. And then we got to check in our original. So this is 3 times the absolute value of negative 8 times negative 3 plus 8 is equal to 80. And that's 3 times the absolute value of 24. And that's just going to be 3 times 24. Use PEMDAS, order of operations. You do this multiplication first. You get 72 plus 8 equals 80. So 80 equals 80. Woohoo! And we do the same thing with positive 3. It's going to be 3. There we go. Now you're going to have a negative 24 inside your absolute value. But the absolute value of negative 24 is just positive 24. So it ends up being the same thing that we had. Order of operations, we get 72 plus 8 equals 80. So 80 equals 80. Woohoo! And now the easy one. Why is that not a valid question to ask? Because an absolute value can never be equal to a negative number. And that's all you have to write. An absolute value can never be negative. Alright, let's see how I did on time. Ooh, not bad. Alright. See you guys next time. Peace out.